polynomial and rational functions. I'm looking at the following function. I want to determine the degree of the function, the domain, the range, the zeros, the x-intercepts, and the y-intercepts. So if we took time and we distributed here by FOILing, and then we distributed the x and the 2x and the x and the -1, and we multiplied this all up, we would find 1, 2, 3, 4, 5. This would be an x to the 5th power, x to the 5th, x to the 5th. And so when they say what is the degree, it means what is the highest exponent on the variable. So this is a 5th degree function. Now also you need to remember what we learned back in first semester. If I multiplied this all out, there'd be a 2 in front. And so when it is odd and we think about the end behavior of a function, when it's odd, it's either going to go up on the right and down on the left, or it's going to go up on the left and down on the right when we look at that end behavior. Now how do we determine that? We determine it by the leading coefficient. So the leading coefficient is positive, that means up on the right and down on the left. So how does that impact when we determine the domain and the range of this function? So as it goes up to the right, it will continue to move to the right as it goes up, and it'll continue to move down as it goes to the left. So my domain is all real numbers along with my range. The range is also all real numbers because there's no limit how far it goes down or how far it goes up. What's another way we could write that? We could write the domain of function A is equal to all real numbers, and the range of function A is also equal to all real numbers. Okay, where are the zeros or the x-intercepts? I could take each one of these factors. I set it equal to 0. So I have zeros at -1, at +5, at -2, at +1, and at +3. And the same thing is for the x-intercepts. So my x-intercepts would take those following points, and I'm going to write it as an ordered pair. How do I determine the y-intercept? It should not be intercepts. There's only one y-intercept of a function. Okay, so I'm going to replace 0 with the x. So this is 2 times 0 plus 1, 0 minus 5, 0 plus 2, 0 minus 1, and 0 minus 3. And now on the right-hand side, let's figure out what is the outcome to this. 2 times 1, -5, 2, -1, and -3. And I just want to make sure. Okay, so let's multiply here. I have 2. 2 times -5 is -10. There's -20. Here's +20. +20 times 3 is going to be -60. So I could write down that when we have x equals 0, our output or our y-intercept is going to be -60. Let's look at a second example answering those 5 basic questions. What is the degree, the domain, the range, the zeros, and then coordinates for the x-intercepts and y-intercepts. All right, well I can already see that I have here, I have degree 2, so it's the second degree function. And now let's take a look at what this kind of looks like when we have an even exponent here. So it's a degree that is going to be even. It's going to be up on the right and up on the left, or it's going to be down on the left and down on the right. How do I determine that? I determine that by the leading coefficient. Because it's negative, I know it's going to go down on both ends. So it's looking something like this. So I know right away the domain for function B is all real numbers. And I know that because there's no limit how far it goes to the left as it goes down, and there's no limit how far it goes to the right as it also is being pulled down. The range is a little different. I need to know what that vertex is. And we don't have a calculator available for us. So how can I do this? Well, I know that I can find the vertex by using the equation -b over 2a. So x equals -4 over 2 times -4. X equals 2 negatives make a positive, and so I have the x coordinate of the vertex is going to be -1/2. Now I need to figure out what the y coordinate of the vertex is. So I want to come up here and I want to go, okay, -4, and then I want to take -1/2 times -1/2 minus 4 times -1/2 plus 15. And what this is going to do is this is going to give me the outcome for the vertex, or the y coordinate of the vertex. Multiplying across here, -1 times -1 is 1, 2 times 2 is 4. Okay, so the 4's are going to be reduced down to 1, and I'm left with -1. Or I could have said -4 times 1 is -4, -4 divided by 4 is -1. Okay, two negatives multiply to give us a positive, and half of 4 is 2. I'm going to keep moving this up here. And now when I combine, I get 1 plus 15 is 16. All right, well, how does that help me with the range? This tells me that if I go over, so if I was going to draw a little more accurate picture of this, I'm going to go over to 1/2 and all the way up to 16, and it's looking something more like this. So the range for this function, the range for function b, is all y values such that y is less than or equal to 16. Now in interval notation, we could have expressed that as making sure this is a parentheses. There's no limit how low it goes, and it goes up as high as 16. We need to include that. Same thing here. We could express the domain as negative infinity to positive if we prefer that. All right, what's the next thing? The next thing is the zeros, which is directly related to the x-intercepts, and then the y-intercept. Let's see if this is factorable. If I can't factor this quadratic formula, then I'm going to use the quadratic, I'll use the quadratic formula to solve it. I should have said quadratic function if I can't factor the quadratic function. Okay, 15 times negative 4 is negative 60. I'm looking for two numbers where the difference is going to be negative 4, but they multiply to give us a negative 60. I think that's not going to work. Let's see here. 1 and 60, 2 and 30, 3 and 20, 4 and 15. Is that right so far? 5 and 12. Let me go back here really quick. That's good. That's good. What else is there? 6 and 10. Oh, 6 and 10, the most obvious one I missed. The most obvious one. Okay, in order to achieve a negative 60, they have to be different signs, the larger one being negative. Let's just make sure that works. That does work. So I'm going to give myself a little bit extra room here using these two numbers. So I'm going to start by writing down negative 4 here. Let me just move this up here so we have a little better visual of this. And I'm factoring using the A, C plus B method. So there's my A, there's my C, and I'm going to take the two numbers that I was able to identify to achieve the product and the difference. And now I'm going to use factoring by grouping. What can I factor out? I can factor out a negative 2x, that works, negative 2x, and I'd be left with 2x plus 5. I want to make sure I did this right. There's negative 4x squared and negative 10x. Okay, good. And positive 6x and positive 15. Okay. What does the front have? They both have a 2x plus 5 and then a negative 2x plus 3. All right, so I just rewrote b of x in factor form. How is that going to help me? So in order to figure out the zeros of the function, or eventually our x-intercepts, I'm going to take each one of these quantities, I'm going to set it equal to 0 and solve. So subtracting 5 to the opposite side and dividing negative 5 halves, which could also be represented as negative 2.5, and then negative 2x plus 3 equals 0. I'm going to move 3 to the opposite side, divide by negative 2, and I have a positive 3 halves. So these would be my two zeros, and if I write them in as an ordered pair for an x-intercept, I have 3 halves, 0, and negative 5 halves, 0. So 1.5 and negative 2.5. How do we determine the y-intercept? So this equation, remember, is the exact same as this equation. It's just in a different form, factored form, and this is standard form. When we identify what the y-intercept is, I prefer just to use standard form when it's presented, because in standard form for a quadratic function, the constant at the very back is going to determine our y-intercept. Why is that? Because we're plugging in 0 for x, 0 squared times 4 is 0, 0, so 0 plus 0 plus 15 is 15. So the y-intercept for this problem is 0, 15. Remember, you cannot use a calculator as we go through this. All right, well, what does this look like, and how can I picture what it is without? Take a look right now for a third example. This is the following function I'm given. I don't have a graphing calculator, and so I'm going to make a quick set of data points to graph this. So I substitute in 0, 0 to the 4th minus 16, and I graph it. I plug in 1, 1 to the 4th is 1. Then I go over 1 and up 15. And I plug in negative 1 to the 4th. 4 negatives makes a positive, and 1 minus 16 again is a negative 15. I'll do the same for 2, and for negative 2 we can see that it is going to be symmetrical around the y-axis. And so we can see this basic shape here. So what degree is it? It's degree 4. So the degree for this function is 4. Now what is the domain? The domain of function c, it's going to be all x values. So I should have put, let me go back here. I should, the domain of function c is going to be all real numbers, or we could have put negative infinity to positive. Why is that? Because as it moves to the right, it's going up, so there's no limit how far it moves to the right as it goes up, and there's no limit how far it moves to the left as it also is being pulled up. Now, the range for function c is going to be all y values such that y is greater than or equal to negative 16. Or another way to do that is we could have had negative 16 and then no limit how high it goes. Two different options to write in two different forms. The next thing is zeros. Now, zeros is related to x-intercepts, but they're not always exactly the same. X-intercepts will only ever identify the zeros that are real numbers, that don't contain i's. So let's get started. I'm going to put this in factored form here. X to the 4th minus 16. This breaks in. Remember, we're going to break this in half into x squared and x squared, and 4 times 4. And we can do that because we have subtraction here. So I have x squared plus 4 and x squared minus 4. I'm going to move up. I'm so sorry you couldn't see that. All right, now this is not subtraction, so I can't take that any further. I cannot take that any further. And then I want to go ahead and I want to solve this. And some of you will prefer to break this apart even further, and that's totally fine. But we could stop right here now. So we're going to solve to find out the zeros. Remember, zeros will sometimes be the exact same as x-intercepts, and sometimes zeros will contain additional solutions, because sometimes the solutions will be non-real numbers. Okay, let's get started. I have x squared plus 4. I set it equal to 0. Now I move 4 to the right-hand side. X squared equals negative 4. I take the square root. I'm going to have two answers. X equals plus or minus. This negative sign is going to sneak outside and become an I, and the square root of 4 is 2. So for the zeros, I have positive 2i and I have negative 2i. I will not include those when I list the x-intercepts. Here I have x plus 2 equals 0 and x minus 2 equals 0. I could achieve the exact same thing just setting this equal to 0 and moving the 4 over. Subtract 2 and add 2. I get x equals negative 2 and x equals positive 2. So here is a list of the zeros. There are 4 zeros. There are 4 different zeros. When I have to identify the next step, the x-intercepts, I'm only listing the real ones. So 2, 0 and negative 2, 0. Why did I not get this right? I put the wrong number down here. I'm just finding my mistake right now. Did I do my math quickly wrong? I sure did. I took it to the 3rd. 2 to the 4th, 2 times 2 times 2 times 2 is 16. And 16 minus 16 should have been 0. If you guys were here in person with me, I know kids in my 0 would have caught that. Now, negative 2 to the 4th, negative 2 times negative 2 times negative 2 times negative 2 would also be 0. In my mind, I took it quickly to the 3rd instead of to the 4th. Okay, so I've identified the x-intercepts, the zeros, the domain, the range. I've corrected my graph, so we can now see an accurate representation of this. And my last thing I'm going to do is going to be the y-intercept. So for the y-intercept, we're going to replace the x in the function with 0. 0 to the 4th is 0, and 0 minus 16 is 16. So this is the y-intercept, which we can see all the way down here. We're going to switch this one up. When we look at this problem, the only thing we're not going to do is we're not going to do the range without a calculator. It'd be virtually impossible to do that. It would take so much time. So the exact same 5 steps. But let's get started. So if I went through and I multiplied, I'd have x to the 6. I'd have x to the 6, which tells me this is degree 6. Now, I'm not limited in what I can plug in for x. So the domain of function d is all real numbers. The next is going to be identifying the zeros of the function. So I'm going to take x squared plus 9 set it equal to 0, x squared minus 3 set it equal to 0, and x squared minus 16 and set it equal to 0. Moving the 9 to the other side, I'm going to have two answers. X equals, now the I comes out front. I know the square root of 9 is 3, so 3i and negative 3i. Here I'm going to move 3 to the opposite side. Taking the square root, I get x equals a positive and negative square root of 3. Moving the 16 to the opposite side, taking the square root, I should have two answers of positive and negative 4. I'm going to rewrite these so we can see all. So these are all 6 of the zeros. When I identify the x-intercepts, I'm going to eliminate the imaginary, because the x-intercepts will only be what we can graph in our Cartesian plane. So there's one, another, and our final. Now, how do I identify the y-intercept of this function? Well, I come up, and wherever I see an x, I plug in 0. So this would be 0 plus 9, 0 minus 3, and 0 minus 16. And just for the purpose of time, you guys could take time and multiply to get negative 27 times negative 16. But for the purpose of time, I'm going to multiply here so you guys can see that, and we get a 432. So my y-intercept here is 0 and 432.